So it's 16. So yeah, at that point it will be 16 too. But as Nick pointed out, its velocity is being much higher because its potential is lower. So it's going to be all kinetic energy at that point. The next question says it's going to turn around before it gets to 5 meters. So here's what happens. Basically, this particle is going to be going in this direction. And because it's accelerating, it's going to pick up speed when it gets here. Here it's going to keep the same speed, but it's already going to have a pretty good velocity. Here it's going to slow down. Here it's going to keep going. It's going to go faster, faster, faster. Here it's going to reach a pretty high speed. Here's going to go up, and it's going to want to feel a force that's going to slow it down. The question is, how high does it go? So the highest it can go is when it has normal kinetic energy. Because then it's all converted to potential energy. It's not moving. It's going to go as far as it can. It's kind of go as far as it can until it stops, and it's all potential, which is going to bring it back. But the thing is, we know what its total energy is, it's 16. So that's the most it can have. So let's find out in the graph. And I think UC is 20, so that's about here. And the question says, it'll turn around before it gets to x equals 5. No, it'll go past x equals 5. Because it has enough energy to keep going. It'll keep going until it gets to whatever this point is. And then it'll turn. Are there any questions on that?
That's the turning point, right?
That is a turning point. Because it's reached its maximum potential energy. Kinetic 0.
When the potential is equal to all the energy?
Yeah, no more kinetic energy is captured on that. Just like throwing a football in the air. At the top, it's kinetic is 0, it's reached its max potential. So then here, it's going to go back. What about when it gets here? Does it keep going or does it stop? When it gets back to where it started?
Stop.
Let's make that a quick question. We'll stop with that. So, this last question, when it gets back to where it started, so right here, wasn't A for it stops, and B for it keeps going. So what happens, it's going to go up here, turn around, come back this way. Is it going to stop where it started or keep going? For A, put stops, and then for B, put keeps going. So again, it started here, had initial kinetic energy, 4, goes down, goes up here, stops, turn around. What happens when it gets back to where it starts? Does it keep going or stop? Let me stop recording in a few seconds if we don't have it anywhere. It's the closest vote we ever had it. Almost. Somebody want to defend their answer? Was I really sure about what they think on this one?
It has initial kinetic energy, right? Yeah. So it's got this potential energy and it's got some kinetic energy, so it's like it has some velocity. And so when it goes and comes back, it's going to have that kinetic energy in the opposite direction.
Okay, so he said it has initial kinetic energy, so when it comes back, it's going to still have initial kinetic energy. It's going to have some kinetic energy, so it's going to keep going. Does somebody want to dispute that?
You're told from the beginning that it has 4 joules of kinetic energy, but also only where it's at is only 12 joules of potential. For that thing in the whole, the most it can ever get to of either one is 16 total. So when it goes to the right, it's going to go up to where it's the potential hits 16 joules.
Yeah.
And then when it goes to the left, it's also going to stop at where its potential is 16 joules again and turn around again.
Okay, so you're agreeing with it.
Is that what you true?
Yeah. So the point is, I don't want you guys thinking about this thing going up and down. It's not going up and down. This is a one-dimensional particle. It's going left and right. So let me illustrate to you what it's doing. All right, I'm going to kind of walk it out. So at the beginning, he's going like this. He's kind of picking up speed. Then he's still going. He's picking up speed. And he slows down a little bit. That's the point about 4 meters. And then he gets that little hill there. He's still going. And then he goes really fast and he gets to the bottom of the hill. Bottom of the hill there, he's got his top speed. Okay. And then he starts slowing down a lot. Where am I right now when I turn around?
16.
X equals
16.
Okay, and then I go back and I pick up speed a lot. I get really, really fast. Here I get really fast. And then at that point, at x equals about 6, I start slowing down until I get to 5. And I pick a little more speed. And then I keep going, but then I slow down and slow down and slow down. When I get back to where I started, I still have some kinetic energy left. Because my total energy is 16. And I'm only at 12 potential high. So I'm going to keep going until I get a little further, until I get up to about here. And then I'm going to stop and repeat. It happens over and over again. No energy is lost, it's going to keep going back and forth. Okay, this is not a two-dimensional graph, it's just going back and forth, but it's telling you what to do. With that, you should be able to answer the rest of the questions on that one.